My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and we're the host for today's webinar presented by Versarien PLC. We're joined by Dr. Stephen Hodge, Neil Ricketts, the CEO of Versarien, and Roberto Clemente, the CEO of one of the subsidiary companies of this group. For those of you who maybe are not familiar with the Graphene Council, we were founded back in 2013, and today we are the largest global trade and professional body for this sector. We are formal members of the ISO ANSI IEC Standards Development Group. We provide a weekly graphene intelligence newsletter and reach directly more than 30,000 material scientists in the graphene sector, both in the academic and in the professional spheres. The Graphene Council consists of members that represent academic institutions, graphene producers, intermediary companies, and important end user companies like the Ford Motor Company, as just one example. We're very proud to have Versarien, of course, as one of our members and a long-standing member. Versarien, of course, was the first company to pass the Verified Graphene Producer Program, which involves an in-person visitation from the Graphene Council and inspection of the production facilities and an independent third-party testing of the graphene material produced. And today, the Graphene Council works closely with the Graphene Engineering and Innovation Center at the University of Manchester. We are legally established in the UK, the US, Switzerland, and have an office now established in Brazil. We present webinars like this on topical areas of graphene production and use, including focused white papers on aerospace and the automotive applications. And we also are currently in process of doing an independent third-party testing project on thermoplastic materials for use in composites. And with that, Neil, I want to welcome you and your team to today's webinar and invite you to go ahead and start sharing your screen and tell us what's going on at Versarien. We're really looking forward to this update. So Neil, it's all yours when you're ready.
Good. So I'm joined today by Stephen Hodge and Roberto Clemente from our Nanomap subsidiary. Everyone's used to me talking, so it'll be interesting to hear these guys play their part in the presentation today. As you said, Terence, we're listed on the UK Stock Exchange, so there may be some questions that we won't be able to answer due to regulation and compliance, but we'll do our best. If we can keep the questions more technical, that will be just great as well. So, what is Versarien? Well, we're here to offer the best processes that we can to develop a really wide portfolio of two-dimensional materials and to produce in the highest capacities we can. Graphene is a wonder material, and Steve will explain some of the interesting properties that we've been able to see over the last kind of 10, 15 years. But it's our job to actually create very high-quality graphene. We work very closely with organizations like ISO and with you, Terence, to be able to establish that the graphene that we're producing is reliable and repeatable, and therefore kind of acceptable to some of these big blue chip companies we'll talk about a bit later on. There's no doubt that the higher the quality of the graphene, the better the performance, and we'll show you some of the interesting test results and some of the interesting processes that we've been involved in recently. Just going to show you a quick video.
We'll do our best. Is a pioneer at the forefront of advanced materials innovation, leveraging intellectual property from the leading universities of Cambridge and Manchester. These materials enrich products made by blue chips and small corporate entrepreneurs. Floated on the London Stock Exchange in 2013, Versarien PLC is blazing a trail in material science engineering. Based in the Graphene Engineering Innovation Centre at the University of Manchester and the Cambridge Graphene Centre, our teams have helped collaboration partners to design, test, and manufacture commercially viable products. In 2014, Versarien acquired a spin-out enterprise from the University of Manchester to help it scale up production of high-quality 2D materials. A few years later, the company then successfully acquired a separate business from the University of Cambridge to strategically scale up production of graphene inks. Our global expansion has progressed rapidly, with our business making inroads into North America, South Korea, India, and Japan. And significant links have been established between the People's Republic of China and Versarien, supported by the UK Department for International Trade as Exporting is Great Champions. So what is graphene exactly? At just an atom thick, graphene is incredibly strong. Besides its super strength, it is ultra thin. Graphene is also extremely lightweight, flexible, and transparent. Graphene is an excellent conductor of heat and electricity too. What's more, Versarien's materials are the best available in the market. This is demonstrated through extensive independent testing. Versarien has already worked with a stellar list of groundbreaking companies on projects using our innovative graphene solutions, from solutions in automotive, rail and aerospace sectors to construction, engineering and clothing. From desalination, oil and gas and energy sectors to biomedical applications, miniature electronics devices and fast-moving consumer goods. Versarien continues to work with major collaboration partners to develop large-scale industrial deployment of high-purity, low-defect graphene materials. We look forward to helping you develop your next innovative product. Versarien PLC. Graphene changes the game. Versarien helps you win.
Okay, so a little bit about the group. I was part of the original team that created the company in 2000, at the very end of 2010, the beginning of 2011. And what we identified was that there was a real weakness in the UK about exploiting really great academic research that was being done in some of our leading universities. And we were frustrated that this technology was not making it into the kind of public domain. You know, they weren't making products that that we could buy on the high street. And so what we wanted to do was to work with those academic institutions, the University of Manchester, Cambridge, Warwick, Exeter, Bristol, and so on, to look at the technology that they're developing and then to actually move that on to the next phase. The group itself is split into two different areas. We have the more conventional manufacturing side that looks to exploit these technologies, and then we have the development side, which is under the stewardship of Stephen. The group at the moment turns over about 8 million and makes a very small loss at the EBITDA level. We're well funded through our listing on the UK Stock Exchange, and more recently we've been very successful with a number of grants that we'll talk about. Things started very, very small. So 2 guys in the garage, as all good companies start. And it was kind of 2013 that we really kind of started to mature. That's when we acquired our first company. Ever since then, we've acquired or created a company for the last 7 years. 2014, we moved into the interesting field, which is graphene, this wonder material. We worked with the University of Manchester to come up with a deal that was suitable for us, but also, you know, very beneficial to the university. And we've supported the university ever since with grants and support letters and working to commercialize this IP. 2016, we acquired a more conventional manufacturing business called AAC Chiroma. And the reason we acquired that is so that we could work with graphene in polymers and to really show our customers how that they could be produced. 2017 was a milestone where we actually acquired a second graphene company from the University of Cambridge, and that's when Stephen joined us. And in 2018, we acquired a majority holding in Nanomat, and Roberto came on board. And Roberto is going to be able to tell us all about supercapacitors, mixed metal oxides using graphene, and batteries. 2019, we really started our global expansion, opening up offices in South Korea, China, and the US. And we've kind of continued to explore those opportunities. But in 2020, obviously, we were hit with some very challenging business conditions. COVID hit us in the UK in February, March. And so we only lost 2 days as a result of that disruption in terms of our manufacturing. We've continued to operate all the way through the pandemic, and I believe we've done everything we can to help society to overcome probably one of the biggest challenges I'll ever face. We've been involved in everything from 3D printing visors and making visors at AAC to making bed panels for our Nightingale hospitals, and more recently looking at how graphene can actually be used as an antiviral agent in the long-term battle against COVID. The video explains some of the primary benefits of using graphene, but I just wanted to bring Steve in. And Steve, can you just explain to us, why you were involved in graphene and what you see to be some of the real highlights of this material?
Sure, thanks, Neil. So I think I don't need to go into too many details in terms of what graphene brings to the table, but essentially what we've got here is a unique material, and not just one material. Neil's already mentioned we've got a whole portfolio of graphene-based materials, but beyond graphene, there's a whole other field of probably 2,000 other layered materials with unique properties. So just taking graphene, for example, we've got something which is fundamentally incredibly strong. It's very flexible. It conducts heat faster than conventional materials. And so together, rather than just taking a novel material or conventional material and improving it, we often find that we can add multiple functionalities. So we can make something lighter. We can make it conduct heat better. So we've got a whole set of these primary kind of benefits that we can apply. But often what we're doing when we're developing these applications, so when we're looking at things like coatings on surfaces, we're finding that we're seeing multiple functionalities and we're getting secondary benefits that, in some cases we didn't necessarily expect to find. So, for example, combining our materials, our graphene materials with Roberto's mixed metal oxides, we're now finding that we can actually boost the antiviral or antibacterial performance of certain coatings. What we're doing in some composites applications, where we're initially targeting some lightweighting and structural reinforcement, we're then finding that we can also improve things like the flame retardancy. And these are quite critical benefits that we see, and we can actually replace other conventional materials or compete with other materials that are typically used in certain applications. So Roberto, I don't know if you want to go into other kind of benefits that you're seeing with your hybrid materials, but I think it would be a good point to add that.
Sure, thank you very much, Steve. So basically, everybody knows about what's the interest of the graphene and the huge potential that it has in so many different applications. So what we've done is we have a complementary technology that uses the properties of the graphene, but also with the combinations of nanoparticles of metal oxides. That we do is to add and improve some of these properties. So although the properties by itself has the graphene, we are also adding other properties like antiviral, pseudocapacitant, thermal conductivity, and many others. In that way, that we are doing is to optimize the chances of this material to get into the industry and to make the major impact that this material is supposed to be in the following years. So we have very nice stories. So we traditionally a company that we were developing materials for the specific application of energy storage, but considering the versatility of the material by itself and also the different opportunities within the Versarien group, we are bringing these materials also to other applications and to other industries as well.
Thank you, Roberto. So you can see that graphene offers a multitude of properties that we've probably never been able to exploit as engineers previously. My background in aerospace and automotive was always looking for these kind of advantages in the global market. The opportunity to make things lighter, stronger, and to make them more durable is something that is very attractive to a lot of our collaborators. Okay, so one of the things that we were going to talk about today was a couple of months ago, we were fortunate to be supported by the UK government through their innovation agency called Innovate UK. They're responsible for supporting pioneering research and exploitation of that research. And so in conversation with them, it became very clear that they could find an opportunity to be able to support us with a £5 million loan to scale up a lot of the activities that we were already doing. These were activities that we could only probably do sequentially. So the opportunity to do these simultaneously was very attractive to the company. We've already received the first 1.96 million the government pledged towards us, and we're working hard to achieve all of the milestones that are required. In basic terms, what the government is trying to do is trying to accelerate the use of this material. There's always an interesting dichotomy in between, do you create the capacity first or do you create the market? And in the UK and in Western culture, we generally tend to create the market first. And what we've been doing up to this point is we've been moving along at a very gradual pace, depending on what the customers are asking us. The reality is what we really need to do is we need to create the capacity. And that's why this loan is so important for us. It's split into a number of different areas, and they're not individual projects. They tend to be groups of projects. And the project itself will last over 24 months. The first part, and we'll go into some more detail about these parts in a second, is to scale up the two patented processes that we use. The one that we own, which came from the University of Ulster and the University of Manchester to create graphene nanoplatelets called nanning, and also the GraphInks process, which Steve was working on at Cambridge Graphene before it joined the Versarien group. What we're doing there is we are looking at ways in which we can really accelerate that capacity. In order to do that, we need great applications. So we're looking in this phase is called SEAT, but it's really about how do we use graphene in carbon fiber composites. And as I say, Steve will go into some more detail in a second. Construction is a big area that's really stood still for a number of years. It's one of the largest users of CO, or one of the largest producers, should I say, of CO2. And so, you know, what impact can graphene have in some of these challenges that are creating society? A lot of people ask, you know, what keeps you and the team highly motivated? And the real reason is that we believe that graphene and the materials that we're developing can really make a big impact on our lives. They can really enable some of the technologies that we absolutely need and create, but they also can solve a lot of the problems, whether that be plastic pollution, the development of new materials, electric vehicles, or so on, that are a real challenge for our society. Arch is all about creating polymers and biopolymers. L is all about leisure. That's all about how we use these in consumer goods, how we use graphene in consumer goods. And I'm very fortunate to be wearing a base layer on at the moment. I'll talk a little bit about in a second. And E is the final group of materials that we're hoping to develop, which are the elastomers, the kind of things you find in tires and in seals and so on. You'll see here that we've been working with a number of manufacturers over a long period of time to be able to take what is a very clever scientific experiment and to turn it into something which is very practical. Being able to create a new material is one thing. Being able to then use that material in a variety of different applications is a completely different challenge. And so what we've been doing more recently is we've been expanding our team to bring more people on board that can help us with some of these challenges. These generally tend to be very large organizations, and sometimes it can be very much like David and Goliath. Some of these organizations have more people in their legal teams than we have in our entire organization. And so we have to be aware that we have to have a balance of not only applications, but also types of companies that we deal with. Big companies have the potential for very large orders in the fullness of time. Small companies tend to be very agile, although they're limited by the market penetration that they might have. So what we've tried to do is build a portfolio of these collaborations which kind of overcome those challenges and try to get products to market in a very short period of time. Steve, is there any highlights here you'd like to talk about?
Well, I'm hoping that you'll address the G-Scale leisure projects, but I think some of the supply chain partners that we've brought on board in terms of the leisure and textiles industry, I think really could help solidify us and in our future. So, in particular, the relationship with coats. So, not only are we looking at technologies to coat textile fibers, but we're also quite keen to develop graphene-infused textiles, so we can play around with and see all kinds of benefits when we use graphene in different kinds of applications and different kinds of ways.
I knew you'd steal my thunder somewhere along the line, Steve.
Okay,
so these are some of the more priority projects that we have. So these aren't covered by G-Scale, but are still being worked on in the background by other members of the team, or in times when we're kind of quiet for the other projects. But you can see that we'll talk about some of these a bit later in the presentation, but we're working with Rolls-Royce, we're working with other aerospace groups, we're working with the Advanced Technology Institute in order to try and get these technologies into the aerospace field. But we're also working in medical and leisure, and one of the areas in which we're seeing a lot of activity is in packaging and looking for alternatives to fossil fuel-based plastics. So, Steve, this is your bit now. It's about the scale up and where we are with our graphene processes.
Great. So, yeah, as Neil mentioned, essentially we've got two primary processes for manufacturing graphene. On the first, we've got our nanine graphene nanoplatelet powder production. So that's something that we've taken from the University of Ulster, has been refined at the University of Manchester, and has now been brought to our Cheltenham manufacturing site. And really, we've been able to take that from a 0.5 gram per day sort of batch process, and now we've moved it on to several kilos per day. So really now we're pushing on the order of a few tons per year production. The graphene ink production as well is the scale up is underway, and again that's transitioning from where it was developed at the University of Cambridge, following on from research that I was doing there as a postdoctorate student, and now that's being transferred to our manufacturing site. So because of the scale up and because we've now gone above the 1 ton per year production, of course we'd have to have the right regulation in place. So we've registered as part of the REACH, the registration and regulation for hazardous chemicals as part of the European Chemicals Agency. And this is something that again is really important, and we were able to help drive the commercialization of graphene and drive the scale up of these materials. So the REACH registration, again, is very important, especially as we scale up, understanding the kind of environmental and the toxicological effects that graphene materials might play. And so understanding this and being at the forefront is really pivotal for Versarien. I must also add that with the scale up comes the challenge of batch-to-batch repeatability. And this is something that we've had verified through several institutions, and also through, as we've mentioned, the Graphene Council verification process. So now the challenge is to take this graphene and develop and push the applications into higher TRL levels. So Neil, if you want to go through, I'll briefly discuss each of these in turn. So starting with...
Just one thing, Steve. I mean, don't you just mix this stuff in with whatever you're working with? That's what I keep on being told by everybody, that you just mix some of this powder in and it just works straight away.
I mean, yeah, as we've learnt, in some cases that can be successful, but through the years we've known that really it's a case of working and partnering with companies to develop products together. So every element of these projects involves a huge amount of optimization. So whether you're putting graphene into an epoxy resin for carbon fiber composites, or it's going into a thermoplastic system, there's several rounds of optimization, knowledge transfer that we need to go through to make sure that we can replicate that on an industrial scale. So yeah, briefly, as Neil's mentioned, with the SEAT program of work, here we're looking at reinforced carbon fiber composites. So graphene has been shown to play quite a key role in improving the resin performance, but also improving the interface that resin has with the carbon fiber system. So we've seen improvements such as up to sort of 50% improvements in modulus or tensile strengths of some of these carbon fiber materials. And really what we're trying to do now is aim these and target these for different applications and create demonstrators or large scale components that we can then take to different companies and clients to kind of push these technologies to the forefront. So we've had some previous experience in the aerospace sector. Now we're trying to forge our way in the automotive and marine sector, as well as then also taking a look at some of the consumer goods. Recently, we've announced working with Rolls-Royce, and that's a slightly different collaboration where we're looking at chemical vapor deposition grown graphene directly onto 3D structures such as wires. Can be used in improving the copper for anti-corrosion purposes, and for lightweighting copper cabling within aircraft, which take up a huge amount of volume and weight. So again, in most of these sectors, lightweighting is the key driver. If we can save fuel costs, we can also then not just save money, but reduce CO2 emissions significantly. Do you want to move on to concrete? So this element of work really is not just focused on concrete, but really on all kinds of construction materials, with concrete being the major focus at the outset. So we've partnered with a number of companies, for example, Changemaker 3D and Winsun in China. And what we've already done through preliminary testing is seen up to around 40% improvements in compressive strength. So again, the key driver here is, the concrete sector or construction sector is one of the world's largest CO2 emitters. So around 8% of world's emissions come from cement manufacture. So if we can look at improving such compressive strengths, we can look at lightweighting concrete. We can also, with graphene, we've seen improvements in the curing rate. We've seen improvements in water permeability. So if we can improve things like the lifetime, or improve or speed up the building process, this again will have huge environmental but also financial benefits to constructors.
There's also an element of the other technologies that we're also bringing in here. We're also bringing in knowledge about anti-corrosion and making sure that reinforced steel doesn't suffer from some of the problems. But it's also about bringing in sensor technology. And so there's a whole roadmap of relatively quick wins right the way through to some quite big challenges that we'll need to overcome. Thank you, Steve.
So moving on to Arch. So some of you may be familiar with the work we were doing previously with global construction consultant AECOM in developing a large 3D printed structure. This is something that's been installed and has been under testing for over a year now. So this is a 4 by 2 meter structure, which is graphene enhanced, so improving the mechanical, but also for 3D additive manufacturing. One of the key benefits graphene brings is the thermal properties. So enabling us to tune the 3D printing window, enabling us to print faster, which can speed up the whole construction process. So that's something that I think is going to be pivotal for the construction sector in years to come. But as we say, we're taking this forward. We're also looking at a whole host of other graphene reinforced thermoplastics, whether they be fossil fuel based commodity plastics, high performance engineering plastics, or biopolymers. Each of them comes with their own sort of work stream and optimization so that we can maximize and get the most out of these materials. So for example, in some of these structures, if we want them to, for example, biopolymers tend to be relatively weak or cannot be used in the same type of application as fossil-based polymers. The addition of graphene has been shown to significantly improve their performance, such as they can be used as an alternative or replacement material. And I think that's going to be, again, a key move towards bio-derived materials in the future.
No. So this is one that I'm extremely pleased with. We're making great progress on a number of fronts. We've announced last year that we were working with Mass, and I'm pleased to say that I'm wearing a base layer at the moment that's been produced by Mass that I'm testing. And when I get a chance in a second, I'll take my top off. The first ones of those will be available on our Shopify website after this for a selected number of shareholders and supporters. There are only 75 available that were produced at the same time that we were producing the samples for our sports goods partners. They're keen to see this in production. They're keen to see this actually working. And so those first ones are due for delivery in January, and we've put a number aside for some of our shareholders. You can see here that we're talking about big improvements in things like tensile strength of yarn. We're able not only to alter the thermodynamics of textiles through screen printing and putting the graphene onto the top of the layer, like the base layer that I'm currently wearing, but we're also able to coat the yarns now, and also to include the graphene in the yarn itself. And this is kind of 3 different opportunities for us to really change the way that textiles are produced. With very, very little loadings, we're seeing quite large increases in things like the maximum tensile strength, the ability for that yarn not to rip or tear. But it covers more than that. We're also covering everything from those textiles through to leathers and other areas in which, say, for instance, the soles of shoes, or in the performance textile industry, where we're looking at impact resistance and so on. So this is an area in which I see graphene kind of come into age a lot quicker than some of the other areas. It's going to be much harder to get graphene into structural parts of aircraft, for instance, whereas leisure is much quicker at being able to adapt and to change. And so I'm really pleased with the progress that we've made there. Steve, you're back on for elastomers now.
Thanks, Neil. So yeah, for elastomers, and I should stress that in each of these project streams, we've got key supply chain partners and key customers that we're looking to, as I say, push these applications from TRL between 3 and 6 up to TRL 9 to get them to full commercialization. But in doing so, improve our manufacturing readiness level and move the manufacturing from lab scale to industrial scale. So when it comes to elastomers, we've got 3 key customers. I guess one of the key ones would be in the automotive tire sector. And really what we're doing here is adding graphene, looking at different kinds of loadings and different test parameters so that we can tailor the performance of tires. So we've already seen dramatic improvements in things like the modulus at 100% strain, or different amounts of strain. And the more graphene we add, we tend to improve the performance even further. So it's a case of understanding what is the optimum loading of graphene, where does it make most commercial sense. But what we're able to do here is really tailor and trade off between things like the rolling resistance of a tire, the wear rate, the tear strength, and also the wet performance grip, tailored to different vehicles and different applications. But what I should stress here is, we have end customers engaged. We have potential demonstrators that we can produce, and so we're looking for really these 5 applications to have commercial demonstration by the end of the 2-year program.
Thank you, Steve. I mean, this is another program where there's so many opportunities, everything from the oil and gas industry, where high temperature seals are required in order to make sure that we can continue to drill, right the way through to tires, as you said, and the automotive supply chain, where we're pushing the limits on some of the materials that are currently available. Okay, so that's not the only thing that we're involved in. We've already talked a little bit about the project up at the Graphene Engineering Innovation Centre with Rolls-Royce, and I wanted to talk a little bit about that. We work very closely with the University of Manchester and the facilities there, so that we don't have to keep going to shareholders for plant and equipment that's already been provided by the government. So in Manchester, we're using their chemical vapor deposition, this synthetic way of creating graphene that we've been doing for a long time, but in very small scale. But we can use their facilities and their plant and equipment, which would have cost us hundreds of thousands of pounds, to be able to prove that it works before we have to commit to that. It's a very low risk way of being able to work. It also enables the development of these products and processes much quicker than if we were trying to do it ourselves. The plant and equipment and the experts are all in one building. What we can do is bring along our customers and our expertise in actually making that a mass production process. And so in this particular case, we're working with Rolls-Royce, but there are a lot of these projects that we're working with partners of the GIG. Steve, I know the de-icing project is one of yours. Did you want to talk about that one?
Yeah, so since we're a European-based company, we joined the Graphene Flagship, which is a €1 billion funded project over sort of 10 years. We joined that several years ago as an associate member, involved in some of the Graphene Composites work packages. As of this year, in April, we joined as a core member as part of one of the spearhead projects. So these are sort of commercially focused projects, again, to take something from a relatively low TRL up to commercialization in about 3 years. And so with Airbus as the lead partner of this program, we are working to develop sort of a thermoelectric based heating device, which can work across a number of their aircraft. So not just conventional aircraft, but other things in development, helicopters, and again, we're a number of partners involved, helping us to strengthen our collaborations across Europe in this one.
TDAP is a project that's very automotive related. It's set up by the Advanced Propulsion Centre up at Warwick University, and it's a grant in order to enable the automotive industry to accelerate the use of new technologies, including in this case graphene. They've been very, very good about getting the whole process set up for us so that we can integrate very, very closely with the automotive industry. In this particular case, we've already started working with a UK-based sports car manufacturer, looking at ways in which we can introduce this in order to reduce weight and improve the durability of a range of different materials. It's quite interesting how having a partner like the Advanced Propulsion Centre actually makes these projects work much better. Last week, we announced that we had a defence project. It was worth 1.95 million, and that's a development agreement awarded by one of the agencies over here in the UK called the DSTL. And that's around, again, using graphene in defence applications. Unfortunately, I can't say much about it, as you would imagine that it's a highly classified project. But it does show the significance of our relationship with the UK government and our credibility thanks to things like the Graphene Council accreditation programme. Roberto, I think we've spent enough time talking. I think it's your turn now to talk about all the great things that are happening in Madrid. You've had some tough times over there. You've stayed, carry on working, and you stayed with us. You've done a great job. Can you just tell us a bit about the energy projects and the stuff that you've been working on over in Madrid?
Sure. So, well, as I mentioned before, the things that we are doing is to develop one technology that one very interesting point that is very versatile, meaning that with this technology we can move one product from one application to another with minimal modifications or reformulation. So the nanotechnology is very transversal, as you can see, in all the different applications that we've been tackling. And in here we have a very nice example of how the network and the connections of the corporation can bring one product that is working very well in one application to another. So if we modify also the graphene with our technology, we acquire another dimension to these materials to let them work in a different way. We have different examples. For instance, we've been working in the area of the supercapacitors, and this is not technical. It's not very proper since the technical point of view. Our team would say to you, we are not doing supercaps, we are not developing materials for supercaps, but for pseudocaps. In there we have a very nice examples where we can modify using the versatility of our technology, trying to improve one specific parameter or another. It's something that is very interesting for our final customers. As Neil mentioned before, in most of our cases, the final step of development we are doing with our final customers. So that's why with this versatility, we bring our customers the possibility to make ad hoc or tailor-made materials for their applications. So we have observed that when we manipulate our materials, we can improve, for instance, the energy of one of these energy storage devices, the pseudocapacitors that I meant. Or we can, for instance, improve on some other properties. So depending on the final application, we have a lot of impact or a lot of things that we can improve in those applications. So putting that in parallel with what I said in terms of the versatility, here that we are doing is to improve the pseudocapacitance of our materials. But in the other hand, with the same approach that we are doing is to improve the catalytic properties of some of the materials, and these catalytic properties can be applied, for instance, in zinc air batteries as well. We observe that some of the materials that we have can be applied in this specific application, meaning that with one minimal change in the formulation of our material, we can diversify the market and the application where we can go. And that's part of the approach that we are using. Right? We have three different ways to approach to the market. One of them is the internal expertise that we have in Versarien. We have specifically Nanomat, the part of energy storage. There are some other of the companies that they have also expertise in some other applications. The other one is the great network that we have in Spain and also in UK, the commercial access to some of these companies. And the last one is the access because we have to be very open to hear from third parties to bring our materials to these two applications that I mentioned, but eventually to any other that can be where our materials can be also involved.
Thank you, Roberto. And you've been doing some good work, get some good results on your on the various grants that you've been involved in. We also launched a range of graphene face masks during the year. Obviously, events with COVID-19, very close to our heart with what was going on in Spain, but also in this country. And working with our Chinese partners, we were able to launch a graphene face mask very, very quickly. We got it through all the various levels of certification, including EN 149, KN 95, the antiviral, antibacterial testing, and also the CE marking that's required. And so we've been working on that on a basis of kind of corporate sales, but also supplying some to our shareholders who I know are listening on this webinar. Just to bring you up to speed, we also announced more recently that we've increased our level of cooperation with some of these organizations. I know Carrie was on the list of attendees. But as we've developed and matured, we found that we need better links with various institutions, and Steve and his team needs support in order to bring what is a very big challenge of this new material into the commercial world. And so we've been able to secure a number of really great people to form an advisory panel, including Tony McNally from Warwick University, Andrea Ferrari from Cambridge, James Baker from Manchester, Carrie from the Graphene flagship, but also Branson Bell, who was one of the original research groups and who I first started the discussions around 2D tech with, and Jackie Murray more recently from the Faraday Battery Challenge, where she's the Deputy Director with Innovate. It's very, very important that we continue to have these links and to look at the strategy of the business and to make sure that the strategy is heading in the right direction. So the question is, what is next for graphene? Well, we've seen the creation in 2004, 2005. We've seen lots of acquisitions and developments. We've seen the business move from an interesting science project in a laboratory into an industrial area. We've seen that we've been able to look at collaboration and how it's very important that you have these links with the experts in their fields in order to make sure that you understand everything that's required, whether that be construction or packaging, automotive, aerospace, medical, through to any of the other application areas, including energy. We've seen that there's a real big push on global expansion, and as I said to you before, we now have a base in not only Europe, but the Far East and also in North America. And for me, the next thing that will happen within the market will be a consolidation of the key players and the movement towards the startup culture that's been in graphene, more towards a more mature set of businesses that take on this real challenge. I hope you found that interesting, and now we'll pass back to Terence, and I hope he's got some questions for us.
Appreciate the feedback that we've gotten from your presentations. I want to say from the Graphene Council perspective, because we monitor this global field and have been doing so since 2013, that a lot of what you've just heard from Versarien is echoed through some of the other observations that we see in the marketplace in terms of uptake and maturation of the market, including that last comment about potential consolidation, where we see companies that are further ahead in the commercialization process will continue to lead, and some of the smaller companies that are not quite as far ahead will most likely fall by the wayside or else be acquired. But let's get to some of the questions that were posed here from the audience. So first of all, to Neil, Roberto, and Stephen, you've discussed a lot of the way that you're doing development is these co-development projects with industry partners, which again, from our perspective as the Graphene Council, we've seen this is one of the most successful ways to grow graphene companies and grow the industry. The question that was raised was about how to actually fully commercialize and monetize some of these relationships, and who owns the IP. What's the next stage once you've gone through proof of concept, you've proven an application, and now you roll out into commercial adoption on a larger scale? What's the value capture plan for the company?
So that's quite a difficult question to answer, because it varies based on the different sectors and the different types of companies that we're dealing with. So in some instances, it's purely a supply agreement. They want to get our materials and they want to have access to our IP in order to include graphene into their particular product. They might already have experience of using nanomaterials in their supply chain. That's not normally the case, though, to be honest, Terence. What we generally tend to find is that people don't know how to use this technology, and they want a lot more help than just a supply agreement would give you. But in that particular case, the opportunities around a joint venture or around an IP sharing in the application itself, and then a subsequent royalty stream, are probably the way to go. At the far end, you may have a situation where all they're interested in is the IP, and it's really about a technology transfer and about a royalty arrangement. And we do find that some of the larger companies, that's the way they want to go. The reason for that is because they may be worried about the security of the supply chain. They may be worried about their IP themselves. And so they want to try and protect that. So there's a variety of different ways of being able to solve that problem for them.
Excellent. Thank you, Neil. There are a bunch of questions about the size and scope of the market. And I think, again, if you don't mind, I'll add a little perspective from the Graphene Council. We've done webinars just recently about graphene in textiles, which you've addressed. We are engaged with many companies that are looking at graphene in concrete, polyethylene in the polymer market. Just for your audience to give some perspective, graphene in the concrete applications is a more than 400,000 metric ton per annum market. In just polyethylene alone, we're looking at a potential demand there of close to 100,000 metric tons, so somewhere between 25 to 100,000 metric tons of graphene nanoplatelet type material on a per annum basis. So, the size of the markets potentially for all of these materials are extremely large. And so there's going to be, the challenge of scaling up, which is what, again, the sweet spot that you guys are working on is being able to meet some of that capacity. When we talk about the consolidation, there's another question there about, where does Versarien sit in the food chain kind of thing with, are there concerns about being acquired, or is it more, do you guys feel like you're at the larger end of the food chain?
So when we were looking at consolidation, there's a classic example with Roberto on the call as well. What we were looking at there is actually a relationship which is mutually beneficial for both parties. We had a situation where, when we look at our portfolio, one area that we were very weak in was energy and batteries and supercapacitors. It's an area that we know graphene is going to be very successful in eventually. And so we could try to develop that ourselves, or we could reach out to those people that are involved in that industry. And at the time, Roberto, he'll be able to tell you more about this than I will, but I had a very interesting meeting with Roberto where I said, look, why can't we work together? Why can't we address your issues with our issues and come up with a solution which is far better for everybody? Roberto, is that a fair thing to say?
Yeah, absolutely. It's basically how to put all the efforts together in order to solve the situation. Yeah. From very different perspectives, with different ways in strategies, adding different partners and network. Yeah, absolutely. I agree with that.
And in this particular case, we've been able to use that synergy even better, because Roberto was developing this technology for energy applications. The whole of Europe is engulfed in this pandemic, and lots and lots of challenges, government departments reaching out. to lots of different industries and lots of different institutions. And between us, between the management team, we kind of identified that actually we might have a solution in the form of creating these antiviral treatments. And in this particular case, even though it's not Roberto's core kind of understanding, he's very focused on energy, we were able to use the same technology across a completely different field. Steve helped by being involved in some calls with the University of Cambridge and being able to put it all together. But as a team, we actually came together and overcame a really big challenge, which is how do you create something which actually tackles COVID-19. Steve the company announced recently the team's efforts where we were able to demonstrate, a log4 reduction, 99.99% efficiency of killing these very tricky viruses. And for me, that's how the consolidation works. It's about not one company taking another company, because then you tend to lose something. It's about companies working together. It's about filling those gaps in each other's portfolios, using the strengths. We were already listed, Roberto wasn't listed, so it made access to materials or access to cash much easier for us, which then solved the problem for Roberto and took away some of the restraints that he had in his research. And I hope that Roberto has been happier since we did that, because the company has really matured. And it was the same for Stephen. Stephen came as a product of Cambridge Graphene. He was working with Andrea Ferrari down in Cambridge. And we've been able to integrate that into what we're doing. It doesn't compete with our nanine product, our nanoplatelets. They just operate in different fields. There's a very little crossover in being able to actually bring all of this stuff together. So that's where consolidation really does work. Taking players out of the market is probably not the best thing for the industry, because you need that competition. When I see that we have other competitors, I'm actually, it actually kind of makes me comfortable, because that means that not only are we under pressure when we have to really perform, but also they're making advances that we may not even have thought about. And so competition is great to really drive industry along.
Excellent. Well, thank you, Neil, for that. Just as an observation, I think you make a really important distinction. There are a lot of claims about graphene, and especially its antimicrobial benefits, but there's a big difference between antimicrobial and antiviral. And the fact that you've had testing in that you're actually able to mitigate or destroy or hamper the virus propagation is really an important distinction, because there's a lot of confusion, especially on the retail end or the consumer end of some of these products that claim to contain graphene. And that's one of the reasons why I believe you went through the Verified Graphene Producer program, was to separate yourself out from some of the companies that may make claims, but they're not substantiated. So that's important. There's a number of questions from the participants here about again, IP ownership or how to monetize some of these products. Can you just talk a little bit about the strategy of, if we call it a vertical integration, instead of just producing graphene materials and selling it to somebody and sending them on their way to do whatever they're going to do with the product, is, in the case where you're making face masks would be an example of some vertical integration, or making value-added products. And you've got a range of opportunities, either with energy storage or with the textiles or with the composites, et cetera. Just talk a little bit about what's the strategy for maybe vertical integration and doing some own label products versus white label products versus simply being a supplier, if that makes sense.
So, I'll bring the other guys in on this as well. My experience, and I'd be interested in Steve and Roberto's experience, is that if you try just to be a supplier, your chances of success are very, very low. You're almost in the realms of luck playing more of a part than science, and that's because we don't know about textiles, we don't know about construction, we don't know about 3D printing, we're not experts in aerospace and turbine manufacture and any other area that might be interesting to graphene. And so, and the people on the other side of the table, they're not nanomaterials experts who understand this brand new science. And that's the bit at which you kind of understand how a conversation is going to go is when you start talking about, you know, their understanding of these new materials. Steve, what would you say about integration? You know, I mean, I'm a great believer that we should be as integrated as possible and as far up the supply chain as possible. But Steve, any comments?
Yeah, I kind of reflect that, but all of these industries, it's a massive learning curve for us to kind of learn everything that's involved in manufacturing for different industries, the right regulations to have to follow. So in some cases, it's better to leave that to another supply chain partner. In other cases, you know, we will try our best to try and bring that, and as we say, add value where we can. But I think, you know, graphene's biggest problem is that it can do too much. So there are too many sectors that it can interest and improve performance of all kinds of materials. So
Roberto, you kind of manage relationships with lots of different collaborative partners. Would you agree that that's kind of the way forward rather than necessarily just being a material supplier?
Sure, absolutely. Here, I mean, we need to push more than to pull in many cases. So meaning that we are every day identifying new opportunities. As long as you are in contact with the different partners, you say, okay, I think that I have your solution. In so many cases, okay, this is not the solution that I'm expecting, but this is my specific needs. And okay, I have here something also for you. So this is extraordinarily dynamic. And I think that there's a huge number of opportunities that we find there. Yeah, so when you are in contact, very close contact with the industry, you really realize where are the real opportunities for the graphene, also of our materials as well. As a very good example is what you meant before, right? That we have something on the store and we move in the different application, suddenly it works. So you have to be very, very very open just to identify those opportunities because it's critical for us.
I know Terence is just about to cut us off, so I just wanted to say one. I mean, we don't see ourselves being a white goods manufacturer. We, you know, an end producer. So, for instance, the kind of clothing that I've got on now, that came about as a collaboration with our partner Mass in Sri Lanka. And what we're doing there is a lot of people have heard about graphene, but it's not until you put a product in front of them that they really waken up to the idea that this is something that's going to make a big impact. So if you can show them a working supercapacitor, or you can show them a working battery, or you can show them a 3D printed arch, or you can show them a piece of textile which really does work, then it's not until you get that kind of light bulb moment when they see that this is something that is actually able to be produced and can be produced that they really kind of get excited. And that's why we make these example machines and example products.
Absolutely. And, you know, we do have time for another question as long as people are willing to stick on it. We don't have to cut this conversation too short. But I do want to reiterate what you've said, and again, give some supportive statements based on what we see across the entire industry. And again, the Graphene Council interfaces with end users, intermediaries, graphene producers, raw material suppliers across all these industry sectors. So we get quite an interesting perspective on how this field is maturing. And one of the questions, again, from our audience listening, it was asking about, you know, what they see as the greatest barriers to adoption of this material. And we've seen this whole field move tremendously in the last few years in particular, where, and you've just each of you have reiterated, you guys are experts in the nanomaterial side, really understanding how graphene can be tuned to a particular application, and the end users tend to have quite a low awareness of how to handle some of these nanomaterials, and they're unable to successfully do it without some guidance. So I think, you know, what you are doing with the demonstration projects, the co-development projects, is exactly what's needed to basically grow your customer base in those different fields. So I don't know if you want to kind of add to that. I mean, what do you see as the biggest barrier? What needs to happen for this next stage of large-scale commercial adoption, in your opinion?
I think a lot of what we've been doing for the last couple of years has proven to people that this actually works. And like any new thing, anything that's hyped is everybody expects it to happen straight away, and everybody expects to make money out of it. And the reality is an awful lot of hard work by people like Roberto and Steve and our researchers to actually prove that it can work in a science lab, but it can also work in an industrial environment, in a manufacturing environment. And so I think the biggest barrier to overcome is previously poor material, poor performance that resulted from that poor material, and overcoming that inertia. But Steve, what do you reckon?
Yeah, put me on the spot there. I think, as you say, biggest challenge is educating the customers, and likewise we need to be educated about these different markets. So eventually the light bulbs will click everywhere and light up, and there will be a huge market for graphene materials. And as I say, just takes a lot of collaboration, a lot of development work to get things right. And we need to go through scale up, and I think each of these sectors demands different kind of graphene material that we've seen. That's why we're looking to develop a whole portfolio of materials where we can offer something to every market that's out there.
Excellent. There is one topic that we haven't really addressed and has been asked, and that's about recyclability or total life cycle. And with graphene being a pure carbon material, we've seen different applications where graphene can be added to plastics, for example, and make them even more recyclable, if you will, and to prevent them going into the waste stream. Do you guys want to address a little bit about that, the role that graphene plays? You mentioned a bit about carbon reduction with concrete, which absolutely is a massive opportunity. What's the green side of using graphene materials, either from end of life or at the front end?
So I think it's mainly in the front end. I think we're adding such small quantities of graphene now, if we can get it dispersed effectively, that it doesn't really make much difference to the chemical makeup. It's a question that we get asked an awful lot of. But when you're adding 0.25% by weight, it's such a small component. Now, if those materials are continually recycled, will that graphene element build up over a period of time? It might do, but it might also be lost to waste as well. So in terms of recyclability, I don't see it as having a major impact. At the front end, I think the really exciting thing is around some of these new materials that are replacing fossil-based polymers, or fossil fuel-based polymers, because it's a bit like the aircraft industry. When we used to talk about electric flights in the aircraft industry, everybody thought it was nonsense. When we used to talk about electric cars, everybody used to think about our milk floats. I know you don't have milk floats in the US, but we used to get our milk delivered on these little carts that were electric powered. And so everybody's perception was that electric vehicles would never work and we'd always have to use petrol engines. And I think in packaging, it's the same thing. People are fixated that plastic, especially fossil-based plastics, fossil fuel-based plastics, are the only game in town. But the reality is there's a lot of people working on using combinations of new materials to outperform the old materials. Anything you've got to say, Roberto or Steve?
Well, in our situation that we observed is that in some cases, if you introduce the graphene, for instance, or any product related with the graphene in some specific application, this product by itself is less toxic than the current alternative. So it's something that also can help, right? This is not specifically related with the recyclability of these materials, but eventually that could help. Also, the very interesting is that all the industrial process that we develop is using green raw materials, and we want to be completely sure that the final product is also clean. We have different products internally for confirm this situation. So we agree that there's a lot of things that we are ready to tackle in terms of I said the people working in the community of the nanotechnology, right, with this concern. But there are some other advantages because up front, for instance, this situation we observed that for some specific applications, the market standard, the current market standard is toxic, and the solution that we are suggesting is not toxic. So that's something that also helps in this concern.
Excellent. Well, if you don't mind, Neil, I think I'll pose one more question. If you guys are okay to stick, you still have quite a few people hanging on, listening to the webinar. So if that's okay, I didn't want to lose sight of the energy storage opportunity, and I believe you guys are working, if I'm not mistaken, with graphene and silicon, or some other permutations of that. So can you just talk a little bit, because that's, this goes in hand with what you just said about the internal combustion engine. I mean, if you look at what's happening, you have an all-electric Bentley, you have Rolls-Royce making an electric engine for an aircraft, Pilatus Aircraft has already made an entirely electric passenger aircraft, a small one, but it's there. And then Airbus has its zero emissions project, which is to go to an all-electric hydrogen fuel combo with electric powered engines. So that, without being too dramatic, we've gone from horse and buggy to internal combustion, and we will go from internal combustion to an electric or a hydrogen workforce. Another example of that are fleets in Switzerland now. There's several hydrogen power stations, and a number of the major retailers are having purely hydrogen fuel cell driven delivery trucks. So, that you can kind of see where this is eventually going to go. And so you guys are well positioned for that. And energy storage is going to be, a major enabling technology with a lot of different competing chemistries, no one of which will be the sole, let's say, champion and take all of the categories. And with having said all that, just talk to us a little bit about your view on the work that you're doing in energy storage and what opportunities you see there.
Well, one thing that we didn't mention was one of our Innovate projects, which is FlexiBat, which Steve will talk about in a second. Then Roberto will follow up with his views around energy storage. I actually think one of the biggest areas that we'll see big change will be off-grid storage. So generating huge amounts of renewable energy and then being able to store that. But Steve, do you want to talk about FlexiBat, and then Roberto, can you give your views as the kind of expert in this field?
Yeah, I think briefly the FlexiBat project is a UK Innovate funded project, which not really for EVs, but is more looking at flexible energy storage devices for things like wearables or Internet of Things devices or sort of wireless sensors. So that's something that we're incorporating our graphene materials, not only as a conductive additive, but also as an anti-corrosive agent. So in this application, it's particularly important for the current collector. So the electrolyte chemistries, you mentioned chemistry is important for these kind of systems. Some of these electrolytes can be very corrosive, and so you're limited in the terms of types of materials you can use. And so that's why we're looking at sort of key developments to improve the lifetime cyclability and performance of these batteries overall. But I think the work Roberto is doing and his Nanomat team, particularly exploring all kinds of zinc air and other lithium type batteries, I think is where we need to be focused for EVs.
Sure. Well, we have the perspective from the development of solution for the area of energy storage. Is when you see downstream and what's going on in the area of the different technologies, you see that there are a lot of drivers, yes, governments, geopolitics situations that are trying to drive or to stop some specific applications. So there's a huge situation in here. The following 10 years, it looks like the energy and the energy storage for the rest of the century will settle up. So we are very excited to see what are the energy storage devices that will be supported. Which one of them not? There are some of them that they are trying that they are quite dangerous, but if the 90% of the current energy storage devices are one specific technology, and we will push from the nanotechnology just to integrate our materials in any energy storage device, right? But there's a lot of situation that we have also to consider that is very downstream to the where we can achieve with our developments at this moment. So that's something very, very important, because the EV, for instance, is a huge drive that they conditionate all the developments upstream, from the materials to the integration to the design of the engineering of each energy storage cell. So there's a lot of different components that will define the energy storage of the future, not just the graphene or the nanotechnology. So yeah, it's difficult to answer that question.
No. Yeah, it's an evolving field, but the prize is enormous because there are just so many formats that are going to need these energy storage devices, and the volumes are going to be quite significant. Well, with that, I just want to say on behalf of the Graphene Council, we're extremely pleased to have hosted today's webinar. I want to make it clear to the audience as well, because there are quite a few investors, financial advisors, et cetera, that the Graphene Council is 100% independent. We hold no interest in any graphene companies whatsoever. We don't receive commissions, rebates, or any other incentives. We're a neutral trade and professional body. And having said that, I also want to say that as an objective observer and looking at Versarien and what they're doing, the vertical markets that you guys are addressing are ones that we also see that are evolving. I think the co-development approach that you're doing is quite intelligent, and that you guys are well positioned for the future. And if we look at the market as a whole, based on the conversations we have with end user communities and important intermediary companies that make, for example, resin systems and other types of plastics, polymers, et cetera, that 2021 is going to see some significant upticks in the use of graphene materials in commercial products. We've already seen, I mean, Ford Motor Company is already in its second year of putting graphene into road vehicles on a massive scale, and they're looking at other ways and other parts of the vehicle in which to incorporate it. And the work with these kind of blue chip companies, which relates to another question from one of our audience, does that spur others? Graphene has suffered from the effect that nobody wanted to really be first, and out there, they're all looking for somebody else to prove that it works first, and then we get fast followers. And I think we've worked our way through that period of getting some really good demonstration. The data is being validated not just by a few end users, but also by multiple companies in the sector. And so I think we can speak with a high degree of confidence that this is real, it works, it's effective, it has important applications, more than 45 verticals that the Graphene Council alone has identified. And for those of you who are not that familiar with the Graphene Council, you can subscribe for a newsletter from us. We put it out every week about commercial research and patent filings related to graphene. That's free to subscribe. And so we encourage you to do that. And then Neil, I'll invite you and Roberto and Stephen to make any last comments or closing comments you want, and then we'll end today's webinar.
I knew I'd do it once. just wanted to thank everybody for staying on and listening to us. We've got a really interesting company. We've been on a really, really interesting journey, and long may it continue. Our team is expanding. Stephen will tell you all about some of the vacancies that are available, because we're looking for new team members. But thank you, Terence, for the opportunity to talk this afternoon.
My pleasure.
Likewise, Terence, thanks again, and everyone for listening. As Neil said, we've got some vacancies that we're looking to recruit, and we've got so many projects on the go. So yeah, we've got some interesting positions in our Manchester and Cambridge R&D teams. So the deadline for that application is on Thursday, so do check out our website if you're looking to apply.
And finally, yes, for me, I mean, that the last remark is that I'm extremely excited with the situation where I'm personally where in this moment in terms of the innovation, I have the perception that we are writing the future from companies like Versarien with the things that we are doing. And I think it's something very, very, some points of your life that you realize that you are in the middle of something very important, right? We are in the following years, I think that nothing is going to be exactly the same as today for the things that we are doing today. So, I don't know if it helps, and thank you very much for your time and for letting us talk to this audience. Thanks.
Well, thank you, Roberto. We're really happy to have you, Nanomat, and Versarien as valued members in the Graphene Council, and we will continue to work together to educate, especially the end user markets, about what graphene can do. It's important because it helps us to reduce carbon emissions, reduce energy inputs, make products lighter, faster, better, stronger, which we will all benefit from. So we're very, very excited about the future of graphene and other advanced materials to improve the quality of life for all of us. And with that, I want to say thank you to our audience for participating in today's webinar to get an update from Versarien PLC on what they're doing. And I hope it was educational and informative to you. And with that, we will close today's webinar. Thank you all for participating today.